Hi, and welcome to this K-12 International Academy Flipped Instructional Session. This is Middle School Earth Science Semester A, and I am Mrs. Fessel. Today our topic is Lesson 2.02, which is Minerals and Crystals, Part 1. Your goal for this flipped lesson is to watch this recording before the Class Connect session. Look on your class calendar for the Class Connect flipped follow-up. Our goal during this lesson is to be able to tell apart rocks and minerals and also to be able to identify properties of minerals and what makes them a mineral. To start off, the big question is, what is the difference between rocks and minerals? Rocks are made up of small pieces of minerals. So, for example, if you took these rocks, feldspar, quartz, and mica, they could turn into these rocks: sedimentary rock, igneous rock, and metamorphic rock. As we're going to talk about during this lesson, rocks do not have a specific chemical composition, whereas minerals do. Minerals also have a crystal structure, and rocks may or may not. So we are going to also highlight those key differences during this lesson. So this is the definition of a mineral, and it describes what makes a mineral a mineral. So minerals need to be naturally occurring, solid, and inorganic, with a specific crystal composition and crystalline structure. So that's a lot. So we're going to break it down and talk about what it all means. So the first three things were solid, naturally occurring, and inorganic. So we'll start with naturally occurring. If something occurs naturally, it must not be made by humans. So a substance that can be made in a laboratory but cannot be found in nature cannot be considered a true mineral. So minerals must naturally form in nature. Minerals also must be inorganic, which means not made by living things. So again, kind of similar to naturally occurring, but sugar is naturally occurring because it comes from a sugar cane, but it's not inorganic because it's made by a natural process. So calcite is a mineral that can be made from the remains of once living things, but it is not actually made by a living thing. Finally, we have solid. So this one is probably the easiest of these three. It's not a liquid or a gas, such as ice is a solid, liquid water and water vapor are not. So a mineral must be a solid. Then we have our last few words: chemical composition and crystalline structure. So we'll start with chemical composition. So each mineral is made up of a different element, but minerals of the same type will all contain certain elements. So one of the easiest examples is all diamonds are made of pure carbon. That is its chemical composition, what elements it's made of. Here's some more. Calcite is made of carbon, calcium, and oxygen. Dolomite is made of calcium, magnesium, carbon, and oxygen, etc. Each of these types of rock will always have the same chemical composition. So rocks will not have a certain chemical composition. Each rock can be made of a variety of minerals and elements. And last, we have the crystal structure. So all minerals have a crystalline structure. So what a crystalline structure is usually a geometric shape that you may have learned about in math class. So all crystal shapes reflect a fundamental pattern called a lattice. For example, below we have what a square or a cube lattice looks like. Some minerals have a hexagon lattice. Some minerals have a pentagon lattice. So that's their crystalline structure, how each little atom and molecule forms together to form a certain shape. So for example, the crystalline structure of these different minerals give them their shape. So as the first one right here, the crystalline structure, the arrangement of the atoms ions and molecules that give a mineral its shape. So all minerals have a crystalline structure. Some crystalline structures are easier to see than others. So crystalline structure is an easy way that geologists often use to classify minerals. So here's a couple examples. The mineral galena, you can see in this picture, has cubic crystals. Gypsum has 3D parallelograms, which they call monoclinic. Quartz has a hexagonal or six-sided crystalline structure. Another example is, so this is how crystalline structure can differentiate minerals. Both diamond and graphite are made of carbon, so they have the same chemical composition, but they're different minerals because the carbon atoms are arranged in different ways. For example, graphite is one of the softest minerals because of how its atoms are arranged, whereas diamond is one of the hardest minerals because of how its atoms are arranged. So crystalline structure is very important. So now we're going to talk a little bit about what minerals can be found. So the most common minerals on Earth are made of silicon and oxygen, and in most cases, one or more of these metals, such as aluminum or iron. These minerals, because they have silicon, are classified as a silicate. Earth's crust is made mostly of silicates, such as quartz, feldspar, and mica are common, well-known silicates. So, of the almost 4,000 known minerals, there are only about 30 common minerals, as I mentioned on the last slide, such as quartz, right here, feldspar, mica, and calcite. So, an interesting fact is 60% of the Earth's crust is made of minerals from the group feldspar. All right, so that's the end of our lesson for today. Hopefully you learned what differentiates a rock from a mineral and what scientists look at when classifying something as a mineral. So your next steps are to look for the flipped follow-up sessions in your Class Connect schedule, attend that live session to play games, watch videos, and carry this topic into further practice, and attend a Help Lab session if you need more support. As always, I hope you have fun learning and have a great day.